Okay, today we will see some small definitions on the polynomial. Yeah, the polynomial definitions and zeros of the polynomial. If you can see the next one, I have some definitions here. They will be coming later. Now, what is the definitions of polynomial? Say here, an algebraic expression in x is said to be a polynomial. It has a degree. Suppose an expression of the form ax power n plus bx power n minus 1, which is given here, is a polynomial of degree n and has n zeros. Here a cannot be 0. If a becomes 0, then it will not be of degree n. If a becomes 0 here, it will become a degree n minus 1. If I am talking about the polynomial of degree n, here the leading coefficient cannot be 0. The zeros of the polynomial are just the numbers of time it cuts the x-axis graphically. So examples of polynomial I have taken here: 3x squared plus 2x minus 2, 4x cubed minus 5x squared plus 3x minus 5. Here these are the two examples I have given. Here this one has a degree 2, so it has 2 zeros, whereas in the second one we have 3 zeros. Finding the number of zeros graphically, as I said, the graphically means the number of times the curve touches the x-axis are the number of zeros. Let us have this one. So if I have a first question here, I am not getting any of this line touching the x-axis, so it has no zero. Now when I see the second one, it is touching at one time on the x-axis, so it has 1 0. So here we have 1, 2 and 3 times touching the x-axis, so the third one has 3 zeros. And what about the fourth one? You have 2 zeros. Fifth one you can have 1, 2, 3 and 4 zeros. Like this we can find out the zeros. Now when I talk about the quadratic polynomial, the quadratic polynomial has a degree 2 and has 2 zeros to find. So a polynomial of degree 2 is called a quadratic polynomial, and it has a general equation like ax squared plus bx plus c. It's a very important one. Here the leading coefficient is x squared coefficient, which is a, cannot be 0. It has 2 zeros and that can be solved by using factorization. Graphical representation of quadratic polynomial is parabolic. It will be in U-shaped parabola. It means it is a U-shaped parabola. So graphical representation of quadratic polynomial we will see now. Now we have this one. It is inverted one and it is cutting at a and also a dash. It has 2 zeros, so it's a quadratic polynomial. What about the other one? So here if you see, the U-shaped parabola is touching only at A. Now here, can we say is it a quadratic? Yeah, it's a quadratic. That means it should have 2 zeros. Here the zeros are equal. That means the 2 zeros are x equal to a and x equal to a only. So I have some explanation of quadratic polynomial. This is how we can express, but that the left side you just ignore. If x minus alpha, x equal to alpha and x equal to beta are the 2 zeros of quadratic polynomial, we can express that as a quadratic equation. How? That the equation will be x minus alpha into x minus beta. Here what I did, alpha I have sent the other side, so I got x minus alpha 0 and x minus beta 0. So if you multiply these two, we will get one quadratic equation. That is, on solving we get x square minus alpha plus beta into x plus alpha beta, which you can see here. You can solve, you do rough work, you'll be getting this. Or it is also x square. This, the last one, is very easy to remember. How to get the quadratic polynomial when the zeros are given. It's just simple. You just add these two zeros, you'll get the sum, and you multiply these two zeros, you'll get the product. So you write x square minus sum into x plus product. So here we have some sums. The first one, you have to find the zeros using the splitting of middle term, and the second one, you already have the sum and product. You can do the problem. So let us stop here, this one.